So, guys and gals, let's talk about cancer. When we look at a cancerous cell, or what makes cancer cancer, there are going to be some common characteristics to all cancerous tumors, regardless of what kind of cancerous tumor we're looking at is. One of the main characteristics that makes a cancerous cell is that they don't have full differentiation. And what do I mean by differentiation? In this context, I mean specialization. So if we had a white blood cell that wasn't a fully formed white blood cell, it was a partially formed white blood cell, that could potentially be a cancerous cell. It wasn't fully differentiated. And because these cells are not fully differentiated, they don't have the correct structure and therefore do not have the correct function in the human body. In other words, when we make a cancerous cell in our bodies, we are devoting lots of energy to making cells that do nothing good for us. We're wasting energy. And this is a primary reason why many individuals that have cancers become quite thin, because this cancerous tumor is burning through lots and lots of energy or many, many calories, and it's not performing any function for their body. Another characteristic of cancerous cells is that the nuclei, the nucleus of the cell that holds the chromosomes, is abnormal. This nuclei is going to be extra large compared to the cell itself. And this primarily is because the cells are dividing so quickly, they don't have time to increase the volume of their cytoplasm. They have enough time to meet the minimum threshold for cellular division, and then they divide right away. Sometimes these nuclei also have a few extra or a few less than the normal number of chromosomes. So there's some kind of chromosomal abnormality or genetic defect associated with the nuclei of these cancerous cells. And then number 3, probably the single most important characteristic of a cancerous cell is they can divide forever. They never stop going through cellular division. They have an unlimited potential to reproduce themselves. One of the ways that they have this unlimited potential to reproduce themselves is that they have a special enzyme called a telomerase. And this telomerase is going to regenerate the ends of the chromosome. If we were to look at a human chromosome, a chromosome in a human being is just a big piece of DNA in the cell. Most human cells have 46 big pieces of DNA in their nuclei, or 46 chromosomes. Every time we duplicate a chromosome, it gets a little bit shorter. And then we duplicate it again. And it gets a little bit shorter, a little bit shorter, a little bit shorter, a little bit shorter. Every time we duplicate the chromosome, both ends of the chromosome get a little bit shorter. People that have been alive longer have had more rounds of cellular division than people who have not been alive for a very long time. In other words, old people have had more rounds of chromosome replication, and their chromosomes are shorter compared to younger people. We're all born with sacrificial DNA at the end of the chromosomes. This sacrificial DNA is called the telomere, and its primary purpose is to get chopped up at the end of the chromosome after each round of cellular division. But eventually, in most of the cells of our bodies, the telomeres are going to go away after a certain number of rounds of cellular division. And after we have no more telomeres, we still are going to continue to chop up the chromosomes and make them shorter and shorter, but now we're going to start chopping into functional genes that we need to stay alive. And this is one of the reasons why individuals that are older are more likely to have cancerous cells in their body, because they are much more likely to have started to chop into some potential regulatory genes, or genes that would help keep a cell from becoming cancerous. Cancerous cells have an unlimited ability to divide. They have a telomerase, an enzyme that makes the telomere a little bit longer, a little bit longer, a little bit longer, with every round of cellular division. So every time the nucleus divides and the chromosome is reproduced, the telomere gets chopped a little bit shorter, because that happens when you reproduce the chromosome, but then the telomerase makes it a little bit longer to compensate for the fact that it's getting a little bit shorter every time. In other words, the chromosomes of these cancerous cells stay the same length with each round of cellular division. Any questions? After these cells start to divide uncontrollably, they form a big blob. And the big blob of cells is referred to as a tumor. Benign tumors, or tumors typically, or blobs of cancerous cells that are going to be contained. They are not going to have very rapid migration, and they do not have very rapid reproduction. They are going to be contained typically in a bunch of connective tissue that encapsulates them and keeps that tumor from invading the adjacent tissues in the body, particularly the bloodstream or the lymphatic tissues. If the tumor is metastasizing, or if it's a cancerous tumor, it's going to be rapidly moving and invading other tissues in the body. Another characteristic of our cancerous cells is that they don't need a growth factor, such as human growth hormone, to stimulate cellular division. They are reproducing out of control. And if we look at our cancerous cells, they start to have more and more abnormalities build up. This abnormality that builds, or these abnormalities build up, are associated with a high rate of division. Most cells of our bodies have checkpoints during cellular division, and if they don't meet certain checkpoints, the cell will self-destruct. And this is a way that we have quality control in our body, so that we don't have malfunctioning cells building up. But our cancerous cells don't have those quality control checkpoints built in. They just keep reproducing and reproducing and reproducing and accumulating more and more mutations or abnormalities. And then finally, our cancerous cells can undergo angiogenesis and metastasis. Angiogenesis is a fancy term that means that our cancerous cells can cause the growth of new blood vessels. During angiogenesis, new blood vessels will be stimulated to grow into the tumor to supply nutrients to the tumor, and those cancerous cells then can travel through the new blood vessel to other parts of the body. This process of traveling to a different part of the body is known as metastasis. If a patient has a metastasizing tumor, that is a cancerous tumor that is spreading and moving throughout their body. Metastasizing tumors usually are one step away from death. Oh, looks like I got ahead of myself there where I was defining my terms. Next slide. So, angiogenesis and metastasis are typically two peas in a pod. One involves the formation of new blood vessels, one involves the spreading of the tumor. When we are developing our cancerous cells, these cancerous cells are going to be developed in a couple stages. We first are going to have the initiation stage. This initiation stage begins with one bad cell. It all starts with one bad apple, or one bad cell that leads to this cancerous tumor. And this is one of the reasons why treating a cancer by surgically removing the cancer is in and of itself not a very effective option. All the surgeon needs to miss is a single cell. And if one single cancerous cell remains in the human body when they try to cut out the tumor, then the tumor can regrow from that one cell that's differentiating or growing without any regulation. So first, a single cell becomes mutated and starts to divide very rapidly. Afterwards, that tumor is going to the cell forms a mass, and this mass is going to have additional mutations build up in it that cause it to grow even quicker and spread. So we start off with a cell that has one mutation. These are typically precancerous cells. Most human beings are going to be born with a couple mutations in their body that predispose them to a couple kinds of cancers. In other words, most of us have a lot of precancerous cells built up in our bodies. Sometimes, though, these precancerous cells accumulate additional mutations. So instead of having one mutation, they have two mutations. And as these mutations build up, all of a sudden these cells don't have the regulatory mechanisms that keep them in check. And they start to reproduce out of control. And then maybe another cell within this mass accumulates a third mutation. And that third mutation makes it reproduce even faster and start to spread to other parts of the body. So this right here would be a precancerous cell. This is what we refer to as a benign tumor, one that's not spreading. And this is a cancerous or metastasizing tumor. Questions? Comments? As our cancerous tumor spreads to either the lymphatic vessels or the blood vessels, they will very rapidly spread to the rest of the body. If we look at these cancerous cells, there are two primary genes associated with cancers, or categories of genes. They are the genes that suppress the formation of the tumor itself, or they are genes that regulate the cell cycle. If the cell cycle malfunctions, many times apoptosis will be induced. This is our body's quality control method. If we produce a malfunctioning cell or a mutated cell, our cells are pre-programmed in our body to self-destruct or commit suicide. This self-destruction of the cell is known as apoptosis. Cancerous cells no longer have the ability to destroy themselves when they have malfunctions. Genes that are associated with this are referred to as proto-oncogenes. Oncono is a root word that means cancer. A doctor who studies cancer or treats cancer is referred to as an oncologist. These genes are proto-oncogenes. They are the precancerous genes. We also have tumor suppressor genes, and they focus on the other end of the cell cycle. Instead of promoting cell death when the cells malfunction, tumor suppressor genes are going to limit the amount of cellular reproduction and then promote cell death. So one gene is going to promote the reproduction of the cell. The other gene limits the reproduction of the cell. If we have an overactive proto-oncogene, we could have too much cellular reproduction. If we have an underactive tumor suppressor gene, we could have a tumor develop or out of control cellular reproduction. Another way of thinking of these is one is the gas pedal and the other one is the brakes. And if you have a malfunctioning gas pedal or brake pedal, you can still get in a car accident. So either of these genes can be mutated. Once they become mutated, they become a fully functional cancer gene or oncogene. Questions? Comments? All right. So here are some theoretical genes, and these are just our favorite generic genes. We can have some kind of a growth factor that's received by the cell that's going to activate a gene in the cell that then produces a protein that overstimulates cellular reproduction. So the proto-oncogenes are going to be genes that are associated with stimulating the reproduction of the cells. And then our tumor suppressor genes will have the same sequence of events, but at the very end, instead of producing a protein that stimulates cellular reproduction, they produce proteins that inhibit cellular reproduction. If we look at oncology as a whole, it's a broad field that focuses on the study of cancers. And within the field of oncology, we have several subspecialties or several subfields. We can focus on the study of a carcinoma. That's specifically going to be a cancer of the epithelial tissue. Carcinomas are among the most common cancers. Skin cancers and lung cancers, generally speaking, are referred to as a carcinoma. There can be an adenocarcinoma. That is going to be a specific kind of carcinoma. If we look at epithelial tissues form membranes and they form glands in our bodies. And since we have lots and lots of membranes, think of your skin and everything that lines the organs of your bodies, we can have lots and lots of carcinomas. Occasionally, instead of having a cancer develop from a membranous cell, we can have a cancer develop from the glandular epithelial tissue, and that's referred to as an adenocarcinoma. We can also have a cancer of the connective tissue or muscular tissues. That's referred to as a sarcoma. And if we look at the root word in a sarcoma, we have sarco. Where have you seen that root word before, that prefix, sarco? Yep, the sarcoplasm, the sarcomere, the sarcoplasmic reticulum. That prefix is used when referring to muscle cells. But a sarcoma could also be a mutation of the connective tissues, or a cancer of the connective tissue. So, broadly speaking, all leukemias and lymphomas are subcategories of sarcomas. In most contexts, though, you'll see the term sarcoma referring to connective tissues other than the blood and other than the lymphatic tissues. Leukemia is a cancer of the blood, most specifically associated with white blood cells, and a lymphoma is a cancer of our lymphatic tissues. So, guys and gals, let's have a concept check question. What are the following steps of a cancer progression in order? Your options are: the tumor invades the tissues, the cells acquire the mutation, the tumor spreads, and the tumor grows. So please arrange these steps in the correct order. Our options are 1, 2, 3, 4, 4, 3, 2, 1, 2, 4, 1, 3, and 2, 1, 4, 3. So, what has to happen first? Number 2, let's take a look. Number 2 is acquire the mutation. That is correct. Number 2 needs to happen first. So, we can eliminate that one, and we can eliminate that one. We know it's not A, and we know it's not B. After the cell acquires the mutation, what needs to happen second? Well done, Austin. Our tumor grows. So this is our second step. And via the process of elimination, we know that it cannot be D. Therefore, it's got to be answer C. First, the cell acquires the mutation. Then the tumor grows. Then the tumor invades. And then finally, the tumor is going to metastasize or spread through the vasculature of the body, the cardiovascular and lymphatic vessels. Moving on. What can cause cancer cells, or cancers in our bodies? Well, we can just be unlucky. We can just have bad genetics. You've probably heard of the BRCA genes. The BRCA genes are the breast cancer genes. They are genes associated with breast cancers. And there's BRCA1 and BRCA2 that are genes that can be mutated that predispose individuals for developing breast cancer. So there can just be bad genetics that you inherit. You also can be exposed to a carcinogen. A carcinogen is anything that can cause a cancer to develop. Some carcinogens are radioactive in form. Common examples of carcinogens that are radiation include ultraviolet. Probably the most medically significant radioactive radiation that causes cancer is ultraviolet radiation. In other words, sunlight. And this is one of those give and takes. We need ultraviolet radiation to help us process vitamin D so that we can absorb calcium from our digestive tract. So we need a little bit of ultraviolet radiation. but we don't need a ton of ultraviolet radiation. A typical Caucasian needs to expose their arms and their face to about 10 to 15 minutes of indirect sunlight a day. And that's more than enough ultraviolet radiation to produce their vitamin D requirements. Individuals that have darker skin, if they're maybe of Hispanic descent, or maybe they're of African descent, they are going to need to expose their bodies to a little bit longer dose of ultraviolet radiation because their skin is more pigmented and blocks more of that ultraviolet radiation. What are some other radiations that could potentially cause cancer that you could potentially experience in your everyday life? Maybe at the clinic. Yes.
If you're in that room with they take x-rays?
Yes, x-rays. And I have to mention it because this is Red Wing, Minnesota. We have the Prairie Island nuclear power plant near town. And one thing that I find very interesting about cooling towers on nuclear power plants is that if you stand directly outside of a cooling tower at a nuclear power plant, and you also take a separate person and have them smoke a cigarette, the individual that smokes a cigarette is exposed to more rads of radiation than the individual who spends an hour standing directly outside of the cooling tower at the nuclear power plant. And that's because radioactive isotopes are selectively deposited in tobacco products as tobacco grows.
Containers are buried underneath the ground.
What was that?
The containers, the waste is buried underneath the ground, about 20 feet.
Depending on the power plant, maybe, maybe not.
I know.
Now, if we look at our environmental carcinogens, these are going to be chemicals that we can be exposed to in the environment. And apparently in the state of California, there's a lot more environmental carcinogens than anywhere else in the United States. These carcinogens can include smoke. And I'm going to speak in broad terms because both tobacco and marijuana smoke have been found to contain the same cancer-causing chemicals. So I will say smoke in general, particularly when you look at an incomplete combustion process. Incomplete combustion means that you don't take all the carbons and bind two oxygens to them. In other words, you make something other than carbon dioxide when you burn it. That's the particulate matter that you see in the smoke, or the haze that forms from the smoke. Those hazes from incomplete combustion are going to contain a hydrocarbon chemical cocktail. Many of those hydrocarbons are carcinogens. And then finally, we have viral causes of cancer. And these viral causes happen because a virus will change our nuclear genome as it hides the viral genome inside of our nucleus. And those mutations can build up and initiate cancers. Most notably, human papillomaviruses have been linked to cervical cancer. Questions? Comments? All right, let's look at this figure here. This has fonts that are way too small for you to read, so I'll paraphrase the highlights for you. We have causes of cancer and deaths from cancer. If we look at males versus females, the most common cancer in a male is prostate cancer. The most common cancer in a female is breast cancer. And the second most common for both males and females is lung cancer. Now, if we look at the causes of death, the most common cause of cancer death in both males and females is lung cancer. Lung cancer is the second most common kind of cancer in both males and females, and it's the number one killing cancer in males and females. In other words, even though breast cancer and prostate cancer are more common, they're more survivable than lung cancer. Questions? Alrighty. Let's talk about some of those genetic causes of cancer. We have BRCA1 and BRCA2, breast cancer associated gene number 1, breast cancer associated gene number 2. These are going to be tumor suppressor genes. So these are genes that hit the brake pads, so to speak. And when these genes are mutated, the ability to slow down and inhibit the cell cycle is impaired, and then breast glandular tissue can start reproducing out of control to form the cancerous tumor. There's also the RB gene. This is a tumor suppressor gene that's associated with individuals that have tumors of the eye. And then there's the RET gene. This is going to be a proto-oncogene. And when this gene is mutated, there is going to be overstimulation of the cell cycle. So this is going to be kind of a gas pedal of a gene, so to speak. And this causes thyroid cancers to develop. You can inherit a mutation to either of these genes, or from either of the genes from your parents. Sometimes these mutations occur within you, within your generation. Many times these mutations are going to be passed from generation to generation. And these mutations do not guarantee that you will develop a cancer, but they mean that you have an increased chance of developing that cancer. It is entirely possible to have a mutation to both BRCA1 and BRCA2 and not develop breast cancer. It's very unlikely, but it can happen. On the other hand, it's also possible to have 2 fully functional versions of these genes and still develop breast cancer. These mutations do not guarantee that you develop the cancer, and they are not going to be a prerequisite for developing the cancer either. Questions?
Why do they wait till you're about the age of 40 to do screenings
For which cancer?
for breast?
For breast cancer? The reason you wait, most physicians recommend waiting later in life to screen for breast cancer, is that as we age, we accumulate more and more mutations in our bodies. And we're much more likely to have those cancers present. The statistical chance of having the breast cancer at an earlier age in life is so low that it's not cost effective to screen for it. Occasionally, there will be younger people in their 20s or maybe early 30s that are screened for breast cancer with a mammogram, but they are going to have a familial history of breast cancer and known relatives with those mutations. Excellent question. Any other questions?
Are these the names of the mutations of the cells being mutated?
The
Genes being
The genes that are mutated.
Okay.
So when someone says that they have the BRCA mutation, they mean they have the bad version of the BRCA1 gene or the BRCA2 gene. We also have transposons, or jumping genes in our nucleus. These are genes that will be selectively removed from one chromosome and put it in a different chromosome. Or they can be duplicated, and they can spread and reproduce and replicate throughout our nuclear genome. And as a transposon is jumping around and inserting itself into the cell, it can deactivate genes that we need. For example, let's say we have gene number 1. And this gene number 1 is a gene that keeps us from developing a cancer. But if I take a jumping gene, or transposon, I could insert that jumping gene right in the middle of gene number 1, effectively cutting it in half and destroying gene number 1, initiating a mutation that could cause a cancer to develop. Questions about transposons? Our environmental factors include both ultraviolet light and X-rays. Ultraviolet light comes from primarily the sun and self-tanning lights. We also use a lot of ultraviolet light in water purification and air purification systems. If you have a higher-end HVAC system in your home, you will have an ultraviolet light on the heat exchange coils inside of your air conditioning unit. And that ultraviolet light will cause mutations in the potential molds and bacteria that would grow on those wet heat exchange coils in your house. Many people will also use those ultraviolet lights to destroy any potential viruses that may be filtering and circulating through the air of their home. And the same is true for water purification systems. Many water purification systems will first have a coarse filter to remove large matter, then they'll have a fine filter to remove small particulate, and then once the small particulate has been removed, high-end water filtration systems will run the water over ultraviolet light to potentially mutate the genomes of any viruses that have made it through the filtration process. And then we have organic chemicals. This is your smorgasbord of random chemical cocktails. So tobacco smoke is the obvious one. Other things include heavy metals or dust, particularly asbestos dust, or specific pesticides that have all been linked to increases in the risk of developing cancer. The most common test that's used to determine whether or not a chemical is a potential carcinogen is called the Ames test. And that is a test that involves taking a mutated bacterium that needs a specific amino acid. It does not have the ability to produce a specific amino acid, histamine. And if that chemical is a carcinogenic chemical, the bacterium is going to be mutated by the chemical and start to have the ability to produce amino acids and survive on its own in a non-histamine-rich growth medium. It's the Ames test, if you want to read more about it. My microbiology students spend a lot of time going over it. We have several viral forms of cancer. Those are going to be cancers that are associated with a specific virus. They are not specifically caused by, but they are going to typically be correlated with those specific cancers. So there's poor use of the English language right here. Hepatitis B and hepatitis C have been correlated with an increased risk of developing liver cancer. The Epstein-Barr virus has been correlated with increased risk of Burkitt's lymphoma. HPV, human papillomavirus, actually has been found to cause several forms of cervical cancer. So that's one of the few situations where causation has been established. And then there are two other viruses that have been associated with cancers. We have HIV. HIV, generally speaking, is a virus that attacks helper T lymphocytes in our immune system. But if we do not have the ability to properly regulate our immune system, and we have HIV, a Kaposi's sarcoma. Kaposi's sarcoma is a specific tumor or cancer that's going to be associated with people that have poorly functioning immune systems. Kaposi's sarcomas are an indicator disease of human immunodeficiency virus. If somebody has a Kaposi's sarcoma, they probably have it because they have HIV. And then finally we have HTLV1, which stands for human T-cell lymphotrophic virus. This word tropic refers to tissue growth. This is a virus that causes growth within our white blood cells and causes a very specific kind of leukemia known as hairy cell leukemia. Questions? Comments? All right. So, guys and gals, we have another concept check question. Which of the following is not a potential cause of cancer? We have radiation, inherited mutations, organic chemicals, high fructose corn syrup, viral invasion, and transposons. Go ahead and get me an answer. Alyssa, what do you think? D, high fructose corn syrup, is correct. High fructose corn syrup has not been linked to any potential causes of cancer, despite a lot of bad press that it's received in the last several years. And I'm going to go ahead and stop this recording right now, just to keep it at a reasonable length.